Welcome back. So today we are going to solve Leetcode problem number 852, which is finding the peak index in a mountain array. So we are given an integer mountain array of length n, where the values increase to a peak element and then decrease. Return the index of the peak element. Your task is to solve it in logarithmic time complexity. So basically, we are given with an array where the elements increase, reaches a peak, and then decrease. So our task is to get the index of the element at peak. So suppose we had an array 0 1 0. So here the peak element is definitely 1, since if we were to visualize it using the curves, so 0 would have appeared here, 1 would have reached the value, and suddenly it's a drop again back to 0. So the peak element here is 1 and index is 0 1 2. So index is also 1, so we would be returning 1 as our answer. So let's see how we can solve this. By the way, uh, since the function is monotonic, which is a monotonic function, basically a monotonic function is a function where the values always decrease or increase. I mean, the values are always strictly increasing and strictly decreasing. So if we are able to observe that the given array follows the monotonic approach, so we should think of the binary search algorithm for finding the answer to that to such questions. So how, but yeah, but how binary search would work here? So let's take an example. The second example, suppose the array was 0 2 1 0. You can see 0 is smaller than 2, 2 is greater than 1, and 1 is greater than 0. So there is a pattern. If we were to mark the low and high pointer here, and suppose we get to a point where we found mid to be here. Now, since mid was greater than the element just next to it, I mean the element to the right, which is 0, so we would be reducing the search range by moving the higher pointer to the lower search range. And in the meantime, we should also store the answer of the current element, which is 0 1 2 and 3, which is index 2. We would continue to do so until the current element, which is always the mid element, that is the element at the mid index, always is greater than the element to the right. We would be storing answer in that case only. And if we continue to do so, we would be arriving at a point here at 2 where there would not be any conditions left with us to search for element in the left such that the current element is greater than the element to the right. Since 0 is not greater than 2, so we would be stopping at 2, and as you can see, our answer is also uh, index is also 2, not element 2, but the index of the element 2, which appears to be 1. So we would be returning answer as 1 in this case. I think I was able to explain you, but it would be more clear if I code this up. So yeah, let's go to our editor and code this up. So we are in our code editor. Let's assign the pointers first, low and high, 0 to 0 and high pointer to the last element. Also, we should store the answer. Initially, I'm seeing it to be like -1. Now, let's run a loop until the low pointer is less than equal to the high pointer and get the mid in the meantime. Let's also store the element at mid and name it as current element. Now, let's check if the current element was greater than the element to the right, which is mid +1. So we would be reducing the search range. That is, we would be moving towards the right. Also, in the meantime, also we should store the answer. Else, if that was not the case, so we should also reduce the lower search range to go towards the higher search space. So low should move to mid +1. So yeah, this was it, and we can return answer. So let's see. Also, the check should be in bounds. So also let's keep track of the mid index, and it should not, I mean, cross. Also, let's store the length. It would be better not to compute values again and again. It should be n-1. And yeah, if it's less than n-1, and uh, yeah, this is the boundary check. So let's see if this works. And yeah, it worked. Also, let's try to submit our code. And yeah, it got accepted. So this was the code, and it's the first thing is ki figuring out how to approach it. If we are able to get the means crux of the problem, then it becomes pretty easy to come up with a valid approach. And this is quite intuitive uh, in my way. Means it seemed to me quite intuitive to code this problem in this manner, and it worked. And you can also see it's pretty efficient as well, and follows the logarithmic time complexity foundation. So yeah, this was it, and I hope to see you soon in the next video.